Good evening, students. Uh, this is my sixth video, I think, and today we have to discuss about the transport number determination using moving boundary method. We already discussed the heat up method. How do you determine the transport number using heat up method? Today I have the second experiment in which you have to determine the transport number using moving boundary method. That means determination of transport determination of transport number using moving boundary method. Moving boundary method. I already discussed this moving boundary method previously. The same process we have to do, and in this case we have to first draw the diagram. In this diagram, what you consider now a vertical uniform bore tube. A vertical uniform bore tube. This is vertical uniform bore tube. Then in the uniform bore tube, both anode is present at the bottom, and cathode is present at the upper end of the tube. This is the cathode portion, bottom is the anode portion. The anode is made of cadmium metal. This is the anode method. This is the cadmium. This is the cadmium. We call it as cadmium anode. Anode is always present at the bottom, and cathode is present at the upper end of the tube. It is made of platinum foil. It is made of platinum foil. This is the platinum foil, which is called as cathode. Then what happens? Now we have to in this case I just tell you now that this contains HCl. Upper portion is consist of HCl, hydrochloric acid. Bottom portion contain cadmium chloride, CdCl2. This is the cadmium chloride present at the bottom, which is the anode, and upper portion is hydrochloric acid we kept, and this is made as cathode. This cathode is connected to a battery. This cathode is connected to a battery. This cathode is connected with a battery, and this battery, when it comes, then this battery has some rheostat like resistance. Then this anode contain a coulometer. We already told you coulometer means from which we can determine what is the amount of current in the instrument it is passed. This is called coulometer. Coulometer may be copper coulometer or silver coulometer. Any method you can take. Then from this coulometer towards the internal resistance, just like rheostat. Okay, this is the copper coulometer from which we can determine the total quantity of electricity passed through the tube. And this is the battery. This portion is the battery is connected, and in this case this is the cadmium chloride solution. This is the cadmium anode. This is the platinum fluid. this is the HCl solution, and this you mention this one is X, this point, and this point is you mention Y. This is called moving boundary. This is called moving boundary, and this distance is L centimeter. This distance is L centimeter. This is the total construction of the moving boundary method. That means in this construction part, whatever you write, now in the construction you have to write that. In the construction you have to write that the moving boundary method consists of the moving boundary method, the moving boundary method consists of a vertical uniform bore tube. This one, from this to this, it is a vertical. This is a vertical position it was kept. That is why it is called vertical uniform bore tube. That means the bore is uniform. Whatever this to this distance, same as here, same is here, same is here also. So it is a uniformly bore tube. This distance in everywhere is same. That is why it is called uniform bore tube. The lower part of the tube consists of anode. The lower part of the tube, or you call bottom or lower part of the tube is called anode. And it is made of cadmium. Okay, then the upper portion of the tube, the upper portion of the tube is called cathode. It is called cathode. It is made of platinum foil. It is made up of platinum foil. The lower portion is called as anode, made of cadmium. The upper portion is called as cathode, made of platinum foil. Then the cathode is connected to the battery. The cathode is connected with a battery. And the anode is connected with coulometer. Coulometer may be copper or silver. This coulometer will tell you what is the amount of current is passed through the tube. It will tell what is the total amount of current passed through the cathode, anode and cathode. It will tell you the total current it passes. Okay, this is the totally the construction part, and also it contain in construction part you can tell that HCl is kept in the cathode and cadmium chloride is in the anode. In the discussion you have to write this one. So this is all about the construction, how the moving boundary method is constructed. Then discussion. In the discussion, whatever you write that the moving boundary method in the determination of transport number, 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 the moving boundary method, the moving boundary method is very accurate, very accurate. Moving boundary method is very accurate and very accurate and simply very accurate as well as very simple. In the determination of transport number, the moving boundary method is very accurate as well as very simple. In order to determine the transport number, this moving boundary method depends upon this moving boundary method, this moving boundary method depends upon the direct observation, the direct observation of the direct observation of the migration of ions, of the migration of ions in an electric field, in an electric field. So the determination of transport number, moving boundary method is very simple and accuracy also very high. And this moving boundary method depends upon the direct observation of the migration of ions in an electric field. In order to determine the transport number, in order to determine the transport number, determine the transport number of proton H plus ion. In order to determine the transport number of H plus ion, the hydrochloric acid HCl can be used as the principal electrolyte. Can be used as principal electrolyte. So in order to determine the transport number of proton, the HCl can be used as the principal electrolyte, and the HCl is kept in cathode. This HCl is kept in cathode. Similarly, the second electrolyte should contain same anion as that of principal electrolyte, should contain the same anion as that of the principal electrolyte. That means the principal electrolyte contain chlorine as the anion. So you choose second electrolyte in such a manner that the second electrolyte should contain the anion chlorine. Okay, that means the HCl is kept in cathode. The second electrolyte should contain the same anion as that of the principal electrolyte. That means in the primary electrolyte, in the principal electrolyte, chlorine Cl minus is the anion. The same anion is also present in the second electrolyte. So you choose such a electrolyte, it should contain same anion as that of the principal electrolyte. And also the movement of the cation in secondary electrolyte should less than that of principal electrolyte. That means H plus. So you choose second electrolyte in such a manner the anion present in the principal electrolyte should contain the same anion as that of the second electrolyte, as well as the movement of second electrolyte cation should be less. The movement of cation in second electrolyte should less than that of the principal electrolyte. Hence, cadmium chloride is a suitable secondary electrolyte second electrolyte sodium chloride is suitable second electrolyte is used for the principal electrolyte HCl. So cadmium chloride is suitable. So this second electrolyte is called indicator electrolyte. That means for this secondary electrolyte, this indicator electrolyte is present. This indicator electrolyte is present in anode. Indicator electrolyte is present in anode. So this is the discussion part. That means you choose second electrolyte in such a manner that the cation present in indicator electrolyte or second electrolyte, in this case cadmium, this cadmium whose movement is less than that of the H plus ion. That means the cation present in indicator electrolyte or second electrolyte, the movement of the cation in the second electrolyte should be less than that of the H plus cation. A second thing is that whatever be the anion present in principal electrolyte should contain same anion in indicator electrolyte or second electrolyte. These two things you have to remember. You have to choose indicator electrolyte or second electrolyte in such a manner that the anion present in principal electrolyte, here principal electrolyte is chlorine Cl minus, the same anion is also present in the indicator electrolyte. In the indicator electrolyte also chlorine. And second thing is that the moment of the second electrolyte cation, in this case cadmium 2 plus, is less than that of H plus cation of the principal electrolyte. So these two things you have to remember while choosing the indicator electrolyte. Then next is, and this indicator electrolyte is present in anode and principal electrolyte is present in cathode. Then working principle. Working second thing is that working principle. Working principle. In the working principle, what you do now, in this case, the concentration of the HCl and cadmium chloride, the concentration of the electrolyte, the concentration of the electrolyte, the concentration of electrolyte means HCl and cadmium chloride is chosen in such a manner, is chosen in such a manner, is chosen in such a manner that the principal electrolyte, HCl will float over the indicator electrolyte cadmium chloride. So you have to choose concentration of the electrolyte in such a manner that the principal electrolyte HCl will float over cadmium chloride. So a boundary is clearly visible. A boundary is clearly visible in between the electrolyte. In between the electrolyte. This boundary is X. This boundary point is X. Boundary point X means this point. That means this is the principal electrolyte HCl and this is the cadmium chloride indicator electrolyte. The boundary is visible here, X. That means the HCl is initially before switch on the battery, the HCl is present up to this. From here to here up to this, the HCl is present, and this to this is cadmium chloride. That means this HCl is present up to this. It overcomes this one and here up to this, and cadmium chloride is up to this much. From bottom to this much is cadmium chloride. From upper to this much is hydrochloric acid. So a visible boundary is clearly visible in between the two electrolytes. So you have to choose concentration in such a manner that there is a visible boundary exists between the two electrolytes, and principal electrolyte should float over indicator electrolyte. When the electric current is passed, when the electric current is passed, then the boundary moves towards the cathode. So when a small amount of current is passed, or when we make the switch on, the visible boundary that means point x. That means the visible boundary x moves upward towards the cathode up to point y. Up to this point this boundary will move. That means then the boundary moves towards the cathode. The point x is shifted. The point x is shifted to the new point y. The point is shifted towards the new point y because the cation H plus followed by cadmium 2 plus ions move towards cathode. That means the cation H plus, which moves very fast, cadmium moves very slowly. So when this cadmium 2 plus and this H plus, whatever is present, moves upward, this cadmium also moves upward. So the boundary moves upward to the point y, x to y after certain time. So move towards the cathode. So this is the working principle. But how you calculate? Calculation part. The distance between x and y, the distance between x and y is L centimeter. That means let L centimeter. That means the distance between x and y, this distance is L centimeter. The distance is L centimeter. We have to consider it. Consider this distance is L centimeter. The volume of the liquid moves upward. The volume of the liquid move upwards is L into A, Cc, where A is the area of the tube, cross-sectional area, of the tube. That means cross-sectional area of the tube. That means this area. Whatever cross-sectional area, this area is A. This distance is L. This area is A. This distance is L. When multiply L into area, this volume of liquid moves upward. That means whatever the liquid present in between them, it moves upward. So A is the cross-sectional area of the tube. The volume of the liquid move upwards is L into A. Volume of the liquid move means it is the movement of the hydrogen ion. The movement of hydrogen ion, H plus ion towards cathode is L into A Cc. Cc means cubic centimeter because we take L centimeter, A centimeter square. This is centimeter, this is the centimeter square, becomes centimeter cube, cubic centimeter. Let C gram equivalent, let C is the concentration, of the electrolyte in gram equivalent per liter. In gram equivalent per liter. That means 1000 cc. 1000 cc of the solution contain C gram equivalent. That means concentration is gram equivalent. 1000 cc of solution contain 1 gram C gram equivalent. So 1 cc of the solution contains C by 1000 gram equivalent. Then volume of liquid transfer is L into A. Then L into A cc of the solution contain C by 1000 into L by L into A. This much gram equivalent. It is known that 1 gram equivalent carries 1 Faraday of electricity. Then etic gram equivalent, then 1 gram equivalent carries 1 Faraday. Then this is the gram equivalent, it is moved. So C into L into A divided by 1000 gram equivalent carries 1 gram equivalent 1 Faraday. 1 gram equivalent is 1 Faraday. But 3 gram equivalent is C into L into A divided by 1000 Faraday. 1000 Faraday. And the electricity carried by H plus ion, the electricity carried by H plus ion is C into L into A divided by 1000 Faraday. So the total electricity passed through the electrolyte solution, the total electricity passed to the tube is obtained from coulometer. Let it is Q Faraday. Then the transport number of H plus ion is current carried by H plus ion. Current carried is C into L into A divided by 1000. Current carried by the hydrogen ion by total current carried phi, which is equal to ethic 1. Then we get what? C into L into A divided by 1000 into phi. This is the transport number of H plus ion. In this way, you can find out the transport number of cation. Similar also, you can find out the transport number of anion. So the transport number of anion, hey, କ'ଣ କୁଡ଼କୁଡ଼ କରୁଛୁ? ଯା ରହିଥା ମୁଁ ସାରିକି ଯାଉଛି 2 ମିନିଟ୍ର ମାରି ନ ଦେଇକି ତ ବେକ କାଟି ନ ଦେବି. The transport number of anion, that means Cl minus, is equal to 1 minus T plus by proton. That means we know that transport number of proton by transport number of Cl minus is equal to 1. So 1 minus T spot is equal to transport number of chlorine. That means 1 minus this much, the transport number of chlorine. In this way you find out the transport number of cation and transport number of anion using the moving boundary method. So this is all about. Goodbye. कौन तो मुस्सा के कहीं से आस्तु न पकड़ू सब जाकर तो खाइलू मंडिया सब जाकर खाइलू कौन कहीं जा बस जा ही इस तो पढ़ रहे अरे कौन है क्लासी अरे इंडो कट इधर अरे अरे हे ये तो ऑफ करनी